Hello students, once again welcome you to GK's maths classes. Today we are going to do inverse trigonometric function. This is the fourth video that I am putting on inverse trigonometric function. Today what we are going to do is we are going to basically do problems based on domain of inverse trigonometric functions and also problems like reducing to simplest form depending upon our time that we have. So we are going to do domain of inverse trigonometric functions, where the introduction to all this has been given in the first video, where I will put the link in the description box. So this type of questions are very important of late because of the 1 mark and the 2 mark questions that you have. Okay, so I hope it will be very beneficial to you. So kindly subscribe to my channel and also click the bell icon to get notifications on all videos that you get. I hope these videos are very useful to you. So let us make a beginning. The first question, so I am not going to explain the concept again because it's already done before. The question is, find the domain of the function cos inverse of 3x minus 2. Very important type of questions. So cos inverse of x, you know, cos inverse of x, the domain is closed interval minus 1 comma 1. The domain is minus 1 comma 1 for the closed interval for cos inverse x. So instead of x, what do I have? I have 3x minus 2. I will use black color. So 3x minus 2. So instead of your x lie between minus 1 and 1, since it is cos inverse of 3x minus 2, my 3x minus 2 will lie between plus 1 and minus 1. So my objective is to find x. So I want to get rid of this minus 2. So add 2 throughout. So you get minus 1 plus 2 less than or equal to 3x less than or equal to 3. 1 plus 2, 3. Minus 2 plus 2 is 0. So you get 1 less than or equal to 3x less than or equal to 3. Now divide throughout by 3. So you get 1 by 3 less than or equal to x less than or equal to 1. So clearly your domain is 1 by 3 comma 1. I hope you understand how to solve the problem. Now I will also show you graphically how it looks like. Just watch this. I've already done it and kept. See, this is the function cos inverse of 3x minus 2. Look at the graph. Cos inverse of 3x minus 2. So your maximum value of x is 1 and minimum value is less than 0.5, that is around 1 by 3. 1 by 3 is what is it, like 0.3 something, correct? So maybe you can just zoom in and see a little bit. See, it's somewhere in between 0.2 and 0.4, so it is around 0.3. Maybe I can even further zoom in to see if I can get 0.3. See this? It is somewhere after point. It is 0.33, right? It is somewhere there. So by visually you can also understand this thing. That is why this software is very useful. See, your domain is from 1 by 3. This is 1 by 3. This is 1 by 3. And this is 1. That is exactly what we got in the answer also. Okay, let's go to the next question. I hope this graph is good to understand the things. And it is unbelievable, right? Like you can't draw graph of cos inverse of 3x minus 2 that easily. You are able to get it here. Let's go to the next question. The next question is, I want to find cosecant inverse of 3 minus 2x. How do I find cosecant inverse of 3 minus 2x? So for that, first let me understand what is the domain of cosecant inverse of x. Now here there are two values. One is x is greater than or equal to 1. The other one is x is less than or equal to minus 1. Cosecant don't take any values between minus 1 and plus 1. Correct? Because then sign will become more than 1, which is not true. So here in place of x I have 3 minus 2x is less than or equal to minus 1. First let me exhaust this. So from this I get minus 2x is less than or equal to, take it that side, you get minus 4. Multiply throughout by minus. So you get 2x is greater than or equal to 4. Now divide by 2. X is greater than or equal to 2. So x is greater than or equal to 2. Now again you have 3 minus 2x is greater than or equal to 1. So from this you get minus 2x is greater than or equal to minus 2. Multiply by minus throughout, you get 2x is less than or equal to 2. So x is less than or equal to 1. Okay. So now if I combine both, what happens? This is greater than or equal to 2. So it will be 2 comma closed interval 2 open interval infinity. This is x is less than or equal to 1. Therefore it is minus infinity. You can go up to 1. Okay. This or this, isn't it? So it is or. Or means union. So minus infinity comma 1 union 2 comma infinity. See, problem solving is very simple. All that you need to do is understand what is cosecant inverse of x domain is, and in place of 3 minus 2x, in place of x you replace it by 3 minus 2x and find out what is the suitable value of x is. Automatically you will get the domain and domain for cosecant inverse of 3 minus 2x. Just have a look at it. Let's see the graph. See, this is, instead of cosecant I have written sine. You know, cosecant inverse of x is sine inverse of 1 by x, so I have taken sine inverse. And see, this is the graph. Look at the graph carefully. The maximum value is 1. You see this one, I will zoom out. But there's some part of the graph there also. Now you see, it is from minus infinity to 1 and then from 2 to infinity. This is how the graph of cosecant inverse of 3 minus 2x is. From minus infinity, see there is minus infinity. From minus infinity you come to 1 and then from 2 you go to infinity. That's the answer we got. The domain of cosecant inverse of 3 minus 2x is open interval minus infinity to 1 union closed interval 2 to open interval infinity. Okay. Visually you can confirm it. You know, it's wonderful software to understand things. Let's go to the next one. Look at this. Find the domain of sin x plus sine inverse of x. Very simple. Now let us look at sin x. Now x is angles, right? Sine inverse x, x is numbers. This is angle. So definitely your x belongs to real numbers. All angles. Angles are nothing but real numbers. So the domain of sine is always real numbers, because here for sine the input, the x is angle, but angles are nothing but real numbers, and there is no restriction on angle as far as sine is concerned. Therefore x is all real numbers. Now for sine inverse of x, your x lie between closed interval minus 1 comma 1, closed interval minus 1 comma 1. Now it is combination of these two, so there must be an overlap. So what is R intersection minus 1 comma 1? The real numbers intersection, this will be obviously minus 1 comma 1. So this is the answer. It's a very beautiful sum. And let us have a look at the graph also. Actually I like the graph more because it gives me more understanding. This is the graph, sin x plus sine inverse of x. See what happens. See this is the graph. I'll just move it to this side. This is the graph of sin x plus sine inverse of x, where the maximum value is minus 1, the minimum value is minus 1 here, x value, minimum value is minus 1, x value, maximum value is 1. So that is why we got the domain as closed interval minus 1 comma 1. So visually you can confirm it, okay. So I'll close this. Let's go to the next problem. The next problem is, okay, sine inverse of 1 minus x. So why don't you quickly try? We'll do together. Now, you know, for sine inverse x, the domain is closed interval minus 1 comma 1. So here it is 1 minus x. So 1 minus x should lie between plus 1 and minus 1. Now I want to get rid of this 1. So subtract 1 throughout. So you get minus 2 less than or equal to minus x less than or equal to 0. Correct? I am subtracting 1 throughout. Now multiply throughout by minus 1. So you get 2 greater than or equal to x greater than or equal to 0. You know, when you multiply by an inequality, multiply by a negative sign, the inequality has to reverse. So 0 less than or equal to x less than or equal to 2. This shows the answer is 0, 2. The domain is 0, 2. We'll confirm it visually. See this, so this is the one. You can see clearly it is from 0 to 2. This is the graph of sine inverse of 1 minus x. You see the minimum value of x is 0 and the maximum value of x is 2. So it is from 0 to 2. Beautiful, isn't it? Let's go to the next question. So what is my next question? I want to find cos inverse of root of 1 minus x. Now how do I find cos inverse of root of 1 minus x? Very, very simple. You know cos inverse of x, the x should lie between minus 1 and plus 1. The same logic applies here. So root of 1 minus x should lie between plus 1 and minus 1. Okay. Now you square both because you have to get rid of the square root. When you square both sides, you get 1 minus x is less than or equal to 1. But here what happens, all the negative numbers from minus 1 to 0, when you square the negative numbers, everything becomes positive. So it will come from 0 to 1. I hope you understand that. Because you are going from minus 1 to 1. So in between you cross 0 and then you go. So when you square, these numbers are not affected. Whereas these numbers become positive. So it will overlap there. So it is 0 to 1. Add minus 1 to both sides. Minus 1 less than or equal to minus x less than or equal to 0. Correct? Now multiply by minus. 1 greater than or equal to x greater than or equal to 0. In short, we can write it as 0 less than or equal to x less than or equal to 1. So answer is 0, 1. I hope this is clear. Very simple. Same type of questions again and again. Let's look at it graphically. That is this, right? See this? The minimum value of x is 0. The maximum value of x is 1. Minimum value is 0. Maximum value is 1. That is why your domain was 0, 1. Isn't it? So you can always verify it very easily using the software called GeoGebra. It gives you a better understanding of what you're doing. Now let's do one more sum. Sine inverse of root of x minus 1. I think sine inverse of x, your x lie between minus 1 and plus 1. So you take root of 1 minus x, root of x minus 1. It lies between plus 1 and minus 1. Again, same logic, squaring both sides, you get x minus 1. Here there is no change, whereas here all the negative numbers will be greater than 0 when you square it. Now add 1 to both sides, you get 2. Therefore, x belongs to 1, 2. This is your domain for sine inverse of root of x minus 1. Let's confirm it. Let's confirm it. Always it's better we confirm. Confirm it with this is the function. Now look at it. It is from 1 to 2. The graph will be only from 1 to 2. For sine inverse of root x minus 1 will be, your x will be from 1 to 2 only. Am I clear? So visually it is possible for us to understand the domain. Let me close this. Let's go to the next question. Sine inverse of x square minus 4. So what do I do? You know, for sine inverse of x, your x should lie between minus 1 and plus 1. So applying the same logic here, x square minus 4 should lie between plus 1 and it should be minus 1. Correct? Now what do you do? Add 4 to both sides. So you get 3 less than or equal to x square less than or equal to 5. Square is a problem. Square, inside it has positive numbers as well as negative numbers. So we have to be very careful when you're taking square root because you will have plus or minus. So first I'll take all the positive square root. It will be 3 less than or equal to x less than or equal to 5. Of course it should be root. First is this because I'm taking only positive square root. Now if I take negative square root, it will be minus root 3 less than or equal to minus x less than or equal to minus root 5. So than or equal to x less than or equal to root 3. Okay. Now what happens? Actually it should have been greater than or equal to, because the inequality has to reverse when you take the negative sign. So it's minus root 5 less than or equal to x less than or equal to minus root 3. So the answer will be minus root 5 comma minus root 3 union root 3 comma root 5. Again I want to repeat this. When you take square root, you will have x positive square root, that is root 3 and root 5, and you also have negative, it is minus root 5 and minus root 3. But you cannot just do like this, because when you're taking negative square root, the inequality has to reverse. That is what I'm trying to say. The inequality has to reverse. So the inequality is reversed and we have got this. Let's look at the graph. GeoGebra. Look at this. Actually, I'll just move this slightly so that you can see the graph. You can see clearly. It is from, the values are not very clear here. It is from minus root 5 to minus root 3. Root 3 is minus 1.732. This is minus 1.5. So this will be minus 1.732. Okay, this one. This will be minus 1.732. This will be minus root 5. This is minus root 5. This is minus root 3. This is plus root 3. This is plus root 5. You get a piece. Okay. Let's go to the next question. When you go to the next question, what happens? You want to find the domain of sine 2x plus cos inverse of 2x. When I look at sine 2x, you know 2x can take all angles. So x is all real numbers. X is all, just like what we did for sine x. For sine 2x also it will be all real numbers. There is no change. But here you have to be very careful, because your cos inverse x, your x lie between minus 1 and plus 1. Isn't it? But here it is 2x. So your 2x should lie between 1 and minus 1. Divide by 2. So minus 1 by 2 less than or equal to x less than or equal to 1 by 2. And this is minus half comma half, and this is real numbers, and it is intersection. It's addition, so intersection. The answer will be minus half comma half. Isn't it? Very, very simple question. Okay. Now let's go to the last problem. This is sine inverse of x square. Now how do I deal with this? Now, you know sine inverse of x, your x lie between minus 1 and plus 1, but it is minus x square. So minus x square should lie between plus 1 and minus 1. Correct? Now what do you do? Multiply throughout by minus. So you get 1 greater than or equal to x square greater than or equal to minus 1. That is minus 1 less than or equal to x square less than or equal to 1. This makes no sense, because x square cannot be negative. So it has to start from 0. Correct? So 0 less than or equal to x less than or equal to 1 is the answer. Okay? Very simple. It can't be, it has to be from 0 to 1 only. Let's have a look at it graphically. I have done that also. Look at this. It is from minus 1 to plus 1. I think I made some mistake in the previous one. It is from, it should be from minus 1 to plus 1. Again, I forgot to take the plus or minus. Okay, that's why. I will go back and correct it. So you are taking square root. So it should be plus or minus. So this is one part. The other part must have been 0 greater than or equal to x greater than or equal to minus 1. So minus 1 less than or equal to x less than or equal to 0. So it is from minus 1 to 0. If I combine them, you get minus 1 comma 1. The same thing like what I did here. Since it was 1, I just ignored it, but it is wrong. When you take a square root, it should be plus square root and minus square root. So here's what I should do. Here in this problem, when I take this question, When I take square root, first it's positive square root, no issue, that is 0 to 1. When I take negative square root, 0 less than or equal to x, greater than or equal to minus 1, plus or minus, right? So if you combine them, you get minus 1 comma 1. Sorry for that, okay? Let's see. Now we have finished all the domain question. Now I want to prove some of these wonderful questions. Very simple actually, very important also. I want to prove this result. So what I do, since it is tan inverse of 2, I'll take 2 as tan A. And this is cot inverse of 5, so I'll take 5 as cot B. Okay. Now substitute here. So you get secant square. What is tan inverse of 2? Tan inverse of 2 is A. Plus cosecant square. What is cot inverse of 5? Cot inverse of 5 is B. Correct? Now what is secant inverse of A? It's 1 plus, what is secant square A is 1 plus tan square A, and cosecant square B is 1 plus cot square B. 1 plus 1 is 2, tan A is 2, so this will become 2 square, and cot B is 5, so it will become 5 square. Cot B is 5, so it's 5 square. So what is this? This is 2 plus 4 plus 25. What is that? I think I have made some mistake, I don't know. Maybe this is not the answer. Secant inverse of 2, so 2 is tan A. This is correct. This is cot B. That is also correct. So cot square B will be 25. It will be 4. Yeah, correct. 25, 29. So answer should be 31. Not 15, it should be 31. So secant square tan inverse 2. So 2 is tan A and 5 is cot B. Then this is secant square A plus cosecant square B. Secant square is 1 plus tan square. Cosecant square is 1 plus cot square. Tan square A is 2 square. Cot square B is 5 square. Simplify, you get the answer. Now these type of, we are going to do more questions in the next video about how to reduce to the simplest form. This is one of the most important questions. It has come in the board exam also. Reduce this to the simplest form. Now how do I understand this problem? I understand it like this. If you look at this problem carefully, there are only two terms. How do I understand that? Every problem should be understood like this. A trigonometry followed by an inverse trigonometry. This is one pair. And again you see a trigonometry followed by an inverse trigonometry. It's a second pair. In every problem there will be two pairs. You cannot have trigonometry and trigonometry. It will be trigonometry followed by inverse trigonometry followed by trigonometry. Because trigonometry supplies number and the inverse trigonometry takes that number and gives the angle. Again that angle is taken by trigonometry and gives the number. It goes on like that. So it will be in pairs. So always, as the BODMAS rule, start with the innermost bracket. So I will start with cos of tan inverse x. I will start with this. Okay. Now what I should do? Very, very simple. If it is tan inverse of x, you take x as tan A. If it was cot inverse x, take x as cot A. So what will happen to this? This will become cos A, because tan inverse x is A. So this will become cos A. But what is cos A? Draw a triangle. A, tan A is x by 1. By Pythagoras theorem, this is 1 plus x square. So what is cos A? Adjacent by hypotenuse. So you have got cos of tan inverse x is this. Okay. Now take this and substitute here. Now let me use this. So let me use this color. This is sine of cot inverse of this. Already you proved it as 1 by root of 1 plus x square, correct? You already got it. Now as I told you, it is sine inverse of cot x. This entire thing should be looked at it as x. So I will take 1 by root of 1 plus x square as what? As cot A. So that cot inverse of cot A will be A. So this term will become sine A. Why sine A? Sine of cot inverse of this. See, cot inverse of root of 1 plus x square will be A. So it is sine A. Okay. Now what you do? Draw a triangle. for say, since I used A, I'll use B so that there's no confusion. Okay. So if it is B, what is cot B? Adjacent by opposite. By Pythagoras theorem, this will be 2 plus x square, right? Now what is sine A? Root of 1 plus x square by root of 2 plus x square. Therefore, this result is nothing but root of 1 plus x square by 2 plus x square. Very, very important type. See, you break this problem into two parts. First for the innermost and then for the outermost. Simple. Now, let's do one more question. You see how many terms are there? 1, 2, and 3. Trigonometry, inverse trigonometry. Trigonometry, inverse trigonometry. Trigonometry, inverse trigonometry. Here I used two alphabets. Here I used A and B. Obviously, in this problem, I'm going to use 3 alphabets. Let us see how to go about it. First, I'll take the innermost. What is the innermost? Secant of sine inverse of A. First, I'll start with this. Now, A should be taken as sine A. You know the reason, because it's sine inverse of A. So, I'll take A as sine A. So, what will happen to this? This will become secant A, because this is A. This will be A. Sine inverse of A is capital A. Now, draw a triangle, right angle triangle. Sine A will be opposite by hypotenuse. So, this will be root of 1 minus A square. So, if I apply trigonometric ratios, secant will be hypotenuse by adjacent. So, this is nothing but secant of sine inverse A. I have reduced this to this. Okay, that finishes that part. Now, let's go to the second part. The second part should be cos of cot inverse of, what is this? You have proved this as 1 by root of 1 minus A square, isn't it? Now what I will do, since this is cot inverse of this, I'll take root of 1 minus A square as cot B. Better not use the same alphabet, okay, cot B, because they are not connected. I don't want to get confused. I'll call it as cot B. Now draw a triangle. What is cot B? Cot B will be adjacent by opposite. By Pythagoras theorem, this will be 2 minus A square. Now what will happen to this? This will become cos of, what is cot inverse of this? Cot inverse of this will be B. And what is cos B? Adjacent by hypotenuse. So you have proved this is equal to what? Cos of cot inverse of secant of sine inverse A. So this is equal to this. It's done. Now the last part of it. Now how do I do the last part? The last part is cosecant of tan inverse of this, right? This you have already proved it as 1 by root of 2 minus A square, correct? Now what do you think I'm going to take 1 by root of 2 minus A square as? I think you must have guessed it right. It must be tan C, because this is tan inverse, isn't it? Now what do you do? This will become cosecant C, because this is tan inverse of 1 by root of 2 minus A square will be C. This is cosecant C. Now draw the triangle. Now what is angle C? This will be 1 by root of 2 minus A square. By Pythagoras theorem, this will be 3 minus A square. So cosecant C will be hypotenuse by opposite. Opposite is 1. So basically this has been reduced to root of 3 minus A square. Even though this problem looks very complicated, but if you understand the process, if you break this into parts, definitely it won't be difficult for you. And you can always try more problems in domain and also use the GeoGebra as a tool to understand what you have learnt. I hope this video is very useful to you. With that, we'll stop, and then in the next video, we'll do more problems on how do you reduce a trigonometric ratio to the simplest form, which will also be in turn used in your differential calculus. Okay. I hope it's useful, and please subscribe to the channel and also click the bell icon for notifications. Thank you very much for your wonderful support. See you again in the next class. Bye bye.